Yeah, so then how can we run these microservices? Then we ask a guy from Accenture to come talk about Docker orchestration. Um, switch screens. Yeah, so when we were talking about doing a talk at SaKE, you mentioned, we can do a talk about Docker, and I said, well, nah, well, we've seen that 2 or 3 times before. Can you really bring something new to the table? I said, yeah, sure, we can. We have this amazing demo and this amazing story, which we want to tell with Docker and all the stuff that comes around it. So here you are, and take it away.
Thank you. And it was actually quite funny that these two talks were right next to each other, because the points you have been making about microservices and services have been exactly the ones that we've also been trying to solve, as we might end up with having to run quite large installations and quite large concentrations of services. So I'm Ilkka Anttonen, and I come from our emerging technology, Nordics. And the reason we exist is to take these sort of new technologies and actually fit them into real client environments. So it usually takes a little bit of hammering and getting things ready before they are actually usable in production. So what we set up to do was to give Docker a good run. It's now been over a year that we've been experimenting with it. I think we started with version could have been 0.3 or something. Now it's version 1.5, and it's come quite a long way. We started to develop patterns and different ways to actually get as much sort of extra value from Docker as we can. And one of the patterns we set up with was to be able to do automated load balancing. I mean, if you launch containers, which are excellent for this example I will be showing uses Spring Boot-based, Java-based services. Just for simplicity's sake, they are so complex that they actually return the host name that is running the application and the current timestamp. But that should be enough to sort of show that these actually work pretty much as intended. Unlike this.
We have a service for each display.
Yeah. Okay, anyway, the basic idea is to have the system adapt to the number of running containers on different nodes, so that the service itself that you run wouldn't need to care that it's actually being load balanced or where it's being run. Okay, let's try the old trick.
One sec, look at that. We didn't have the screen on the video stream.
I wonder if it's best to actually sleep this and wake this up.
Prefer to be generation MacBook Pro as I have, then HDMI is pretty fast.
This should be rather new, so I don't think if they've introduced new problems, new bugs, which is also possible because I've now got the spinning beach ball there.
You tried with the adapter?
Yeah, sure. Oh, technology.
Yes. Oh, we're back.
Well, I'll close the lid, see if it makes any difference. Still a little bit messed here.
Yeah. Yes.
When I still get this one back. Well, something definitely messed up here. Let's see if I can do the basic. Does this one work? Can I actually, how the hell can I kill PowerPoint in this one? Anyone with good experience?
I don't know.
Yeah.
Command space, activity monitor, and then
Yeah. So some things never change, it seems. So that's nicely not responding. Let's quit that one. Force quit. Ignore.
I tried.
Yeah, no need for reporting. Yeah. Let's try that one again. Luckily I don't have a long presentation. Let's see if I can get through it this time. Yay! Once again. So the goals: to be able to run easy services, scale them, get the system automatically to load balance. Should be easy enough to do. What we set up to do, or some of the reasons why we wanted to do it with Docker, was that we didn't want to do that much custom code. Of course, you've heard the basics about Docker, so it's single process-based containers, really fast scaling. They share the same kernel than the host, and basically they contain its own build system. You can build containers using Chef, Puppet, Ansible, whatever way you want, but you can also do it with your normal Docker files. We chose to go with the Docker files because, well, that's as close to Docker philosophy as it gets. Usually when people start to use Docker, they first cram everything and the kitchen sink to a single large container, then they advance a little bit and switch their thinking towards more like containerized mindset, which usually means that after a few iterations, you are running single processes per container again. In this example, we took some common off-the-shelf components that all exist in GitHub at the moment and put them together and call that a pattern. So we chose registrator, which sort of ties to the Docker socket, listens to events there. When certain specific events happen, it can do stuff for you. In this case, it registers the service in console. We chose console over etcd as the sort of distributed backend, as well. I happen to like console a lot, so I basically picked it because of that. We have HA proxy sitting in front of the actual business services to do the actual load balancing, and console template sitting on the HA proxy machine, listening to the console and rewriting or doing the HA proxy configuration on the fly when new services get there. So that's how we got around the need to do advanced networking. There are some tools like Weave that allows you to assign IP to your containers. So you can build really sort of fancy multi-node spanning virtual networks. It works, but quite few orchestrators actually support it. Then you can have Pipeworks, which is even more low-level stuff written by Mr. Peraccioni. Works a treat, but then you are modifying IP tables, and it might be that the environment you're running in doesn't allow you to actually modify IP tables by hand. Fleet, CoreOS stuff, also you can do the same thing. What we wanted to do is we want to be as portable as possible. So basically you can run the same setup in your Mac when it works, or then you can run it in Amazon or in Google. So basically we want our patterns to be as sort of adaptable as possible. And one of the reasons was that the services themselves, so the service container shouldn't even know that it's running in an environment with many other services. So basically they all expose their services through the port 80 or 8080, whatever you want it to be. So I chose Spring Boot as an example application. I previously used Node, but Spring Boot and Java-based services are still so widely used. So if the system runs nicely enough doing Java, then you know that anything lighter than that with a memory footprint that is a quarter of the size or similar will definitely run on this. So what we are actually doing is that the console, console is the distributed store right here. And an instance of console is running on all the nodes in this system. So you can have as many service nodes, like I call them, as you want, and then you have one node in front of them actually distributing the load across all the service nodes. A registrator listening to the Docker socket, a service is launched. Docker is really sort of, it tells almost everything that happens inside the Docker daemon and inside the Docker through the socket. So when something is launched, when something is logged, it's all sort of told through the socket. So now we have the registrator listening to it and publishing the stuff to console, HA proxy listening to console, and that's basically how things are load balanced. We have the top proxy sitting in front of all the service proxies, because top proxy then can load balance across as many nodes as you want to. So all the nodes have their own IP addresses, of course. In this example, I will have 3 Vagrant machines running, which have the defined IP addresses. So the only one who knows those is the top HA proxy. So I don't need to hard code any IP addresses anywhere. And when new nodes are added, they are automatically, because the console knows that a new node is added, then the HA proxy configuration for the top proxy is also rewritten. On a small scale animation, it goes something like this. So first you have the service node, you have the top proxy node, you spawn up a new service container. What happens? Registrator listens to the Docker socket, notices this happens, adds it to console, which because it's a distributed sort of service registry, automatically the same information is visible on node 3, which is the top proxy. And after that, what happens? Console template on both is listening to the console, and then the HA proxy is notified. And when we add a new node to the mix, basically the same thing, and stuff should just work. So time for a demo. It's always more interesting with live demos. Let's see if I'll increase the size quite a lot. Is something visible there? Yeah, this should be readable enough. So now I'm in node 1, which will be the first service proxy. So what happens is that I first start the console, I then start the registrator, and I then start HA proxy on node 1. So what happens now is that we can browse the console and see that we have all of that stuff now running. So one HA proxy, then the console's own ports, console itself. Now I can start services. Let's start services on node 1 from say 1 to 3. What happens? The 3 services, 3 containers start. It will take a little while for the Spring Boot applications to start, but now they should be visible here in the console. So now I have hello services here, 3 of them, all passing, and they are all running in pretty random ports. What has happened now in the background is that the HA proxy has been, the HA proxy configuration has been generated, and all of these are now visible on that node on the HA proxy port, which is 8080, and there I have the service called hello. So that happened to go to the node 1, and after a few refreshes, 2, 3, 1, 2, 3. So now I've got the vertical scaling in place. Then I can start the top proxy. This is sort of a way if you want to see that your service, if you, for example, you want to, high availability wise, first run the services on one node, maybe not even join that to the top proxy, see that your new versions work, you can then try it separately and then just publish the configuration to the top proxy. So now here in the top proxy, I'll start console and I start the HA proxy on node 3. I don't need to start a registrator because it doesn't make any sense. There are no services on the top proxy to register. But now what I can do is I can go to the top proxy, and because I want to have a URL based, because if I run different services, now they all each get their own HA proxy. I want to have the URL based sort of service discovery. This service just happened to be called type 1. And the reason for it being here is that the HA proxy here happens to have tag type 1. I could have anything in there. But now we just happen to use the word type 1. So now I have the normal, like the HA proxy doing the load balancing. What can be done now is to run the second node in there. So start console, node 2, start registrator, and start HA proxy on node 2, and then start services. Was the 3 I started there? So let's start services on node 2 from 4 to 6. Give it a little time for the Spring Boot services to start. And pretty soon, as the both HA proxy configurations are rewritten, we should start seeing the new services on the topmost proxy. Still get a few bad gateways when they are starting. Let's give it a little time. Yeah, and there we have it. So 4, 5, 6, 5, 6, 1, 2, 3, 4, 5. So they are now in the game. So basically, now if we shut down something from the first one, so here we can see that we have quite a few different containers running, and the container names hello 1, hello 2, hello 3. If I shut down, for example, hello 2, I should get the HA proxy configurations rewritten, and hello 2 is now gone from the question, or gone from the load balancing. So basically what this allows is pretty nice vertical and horizontal scaling. Of course, in real life, my OSs would be watched by something like Mesos or some other mechanism to actually see the loads, so I could more sanely than just using shell scripts spawn the containers. Logging, which was also mentioned here, what we usually do nowadays is we have like a pattern where we use different containers once again to actually listen to the Docker socket and push all the log messages from there to, well, now we have an example of using Elk stack. So because that's pretty easy to set up. So just push all the messages to a Logstash, which has Elasticsearch as the background, and then with Kibana you can browse the log messages and they can be stored either on the same node or some different node. But like you can see, the Spring Boot containers, the containers themselves boot almost instantaneously, but for the Spring Boot services themselves, it takes a few seconds to boot up. Not too bad. Node a little bit faster. And here I have, well, these services take about 100 megs memory each because of the Java virtual machine that uses Jetty, not Tomcat. And basically what we achieve is pretty sort of seamless auto scaling, or sort of like the rewriting of the HA proxies. You don't need to do anything. You just have the tags correctly and all the other stuff just basically works, which is the way I like it. And the solution doesn't use any custom components. Everything is available, so it's more like a question of packing it up sanely and then just setting it up and running. I guess that's pretty much it. I guess I'm now in time. So time for questions. Yeah.
You talked about regarding cleanup, if you would lose the whole node, let's say you have cut down the node 2, and what would you do after that?
A good question. Consul does clean services from there. So Consul has a heartbeat, but if I now suffer like an unclean, sort of like the severance of the node, I probably would need to clean the stuff from Consul, or at least I will hit those servers a few times before they are actually removed from the Consul, which would then cause them to be removed from the top proxy. So that would probably need some tweaking. Yep.
How much you find Docker in itself? I've heard funny stories about bringing up Spring containers and each having their own scripts and stuff like that. For a very long time they had this text on their own homepage that is not very constructive, but still everybody is using it.
Well, yeah, that sort of changed when they switched to version 1.0 from 0.9. So yeah, just unplug it. That's when they said that it would be ready for production. Quite a few people run it, and it works. We've got like now a commercial partnership with Docker, but we are sort of playing both sides of the coin. So with CoreOS and their Rocket, we also have some stuff going with them. So sort of still keeping our eyes open. I'd say that as containers go, LXC, Linux containers, they have been there for quite a long time, so nothing new there. The Docker sort of just brings like a nice usability layer on top of that. So as for running stuff, I'd say that it's, as long as your kernel is new enough, because you're obviously sharing the kernel, and you're doing same things like not trying to cram everything in a single container, I'd say you're pretty safe. Of course, with the current version of Docker, if the Docker daemon goes down, you're screwed. So that's still something they are actively working on. Okay, thanks. Yep. Well,
Please repeat the question.
about the Amazon EC2 container service, which I guess they call ECS, I have been part of the beta, and I have the keys. I actually haven't logged in because what I'm interested in at the moment is like portability between different players. They have their own things, like they are building their own registry, like Google's container engine, same stuff. Google is of course heavily betting on Kubernetes. Amazon hasn't yet sort of revealed too much information about which orchestrator they are going to use. So at the moment, I'm more interested in getting this same example running both in Amazon, in Google GCE at the moment, and say in OpenShift, V3. They will all have their own tooling. One of the problems is that Docker itself now has things like machine and swarm, which heavily step on toes of some of those players. So I guess it's still a little bit of sitting back, getting a bowl of popcorn and seeing who comes up on top. So basically, when you're building containers themselves, that's not that much of a worry, but about, for example, which kind of registries they will have. Amazon will have their own, Google will have their own. You can set up a private registry in Amazon if you want to, and so a little bit still up in the air, at least as far as I'm concerned.